That's going to be it. I'm not going to do this exam. I can talk about it real quick. We can actually do this just by looking. What would sine of beta be? Can you do it without be opposite of a opposite? Oh, we do have to use the Pythagorean theorem here. Yeah, let's do this one. All right, guys. Who remembers the Pythagorean theorem?
A squared.
Correct. It doesn't give us the hypotenuse, so we have to do 15 squared plus 5 squared equals the hypotenuse squared before we can even solve for sine. You're going to see that come up on the worksheet. Okay? So 25 plus 225 equals c squared. How would you solve it from there?
Square root that.
We'd take the square root of 250, right?
Right.
Now, you can't come up with a decimal. It has to be exact. So we have to break that radical down into something simpler, which I will show you how to do that. Correct. The biggest perfect square that goes into 250 is 25. So I'll write it as 25 times 10. The square root of 25 is 5. So it's 5 radical 10 for my hypotenuse. Okay? So sine of beta would be what? 5 over 5 radical 10, right? Opposite over hypotenuse. There's my hypotenuse now. Now, the 5s will cancel, but then we have 1 over radical 10. We have to multiply the top and bottom by radical 10. So the final answer is square root of 10 over 10. We get about 32%. Square root of 10 over 10. Let's take a look at the diagram. What that means is, again, just for clarification, this side, the opposite side of beta, is about 32% of this side. That's what it means. So if you want to convert the fractions to decimals, it might help you understand what the different trig functions are.